Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy. Let's crack it. So, crack GATE and ESE with India's largest learning platform and get subscription. This is Network Analysis and Transmission Lines Crash Course, Transmission Lines 2, and we'll be dealing with numericals as a part of Lecture 1, Lecture 31. About me, I'm sravan Kumar, having 7 plus years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Click on Unacademy Learning app, type this in your Google Play Store, click on install. That's it. Gets installed, and what you'll get is you'll get daily live classes, structured courses, live test and quizzes, unlimited access. And iconic subscription, you have a personal coach, study tracker, mains question and answer practice, and all the benefits of plus. And in plus you'll get daily live classes, structured courses, live test and quizzes, and unlimited access. And you have the top educators of Unacademy going live for you. You also have many more such top educators, and you have batches for year-long courses: ECE, general aptitude, chemical, mathematics, instrumentation, CSIT, mechanical, electrical, civil and production industrial engineering. And you have plus and iconic types of subscription, where you have the all the benefits of plus in iconic along with some additional benefits. So better always go for this iconic subscription. And you have plus subscription for 1 month, 3 months, 6, 12, 18, and 24 months. You can use my code YSK10 and get 10% discount on this 24-month subscription on any of these subscriptions. For iconic subscription for 12 and 24 months, I recommend you to go for 24-month subscription. Use my code and get subscription to Unacademy iconic plan. Let me tell you about this Evolve for GATE 2022 and Ascend for GATE 2023. This is a 1-year course for third year students. They can opt for this, and for second years this is a very good option, Ascend 2023. We have Vswr for GATE 2022 electrical batch A. You can use my code YSK10 and the top educators will be live. The batch has started on 18. There is another batch coming up. And Vswr for 2023 ECE batch A English, you can use my code YSK10. There is one batch that has started on 18th of January. There are many more batches yet to come. Yes, you can crack GATE top educators teaching live on Unacademy Spark for GATE 2022. 18th of January, use my code YSK10 for ECE. It's an English batch. Similarly, Spark for electrical batch, 18th of January, English batch is started. Use my code YSK10 to get the maximum discount, and the top educators will be live for you. And the topic for today is numericals on transmission lines 2. For all the semester exam students as well as for the GATE and the engineering services students, this is very much helpful, wherein you'll have to solve so many questions. So let's try to start with one simple question. The question says, find the characteristic impedance of a line at 1600 hertz. This is a question. Yeah, if the following measurements have been made on line at 1600 hertz, ZOC 750 ohms, ZSC 500 ohms. So let's try to do this. So what is given to us? Given the operating frequency f is equal to 1600 hertz and open circuit impedance is given. Let's write that. Open circuit impedance is given ZOC as 750 ohms and short circuit impedance is given as well. ZSC is 500 ohms. And find characteristic impedance. We are asked to find what is Z0. So we know that Z0 is equal to characteristic impedance ZOC into ZSC, that is root over 700 into 500 will give us Z0 is equal to 612.37 ohms. Very simple questions. What is given to us? ZOC and ZSC was given, and we were asked to find the characteristic impedance. So at an operating frequency of 1600, so we have taken that. Oh, ZOC is this, ZSC is this, so Z0 will be root over ZOC into ZSC. That will give you 612.37 ohms. Now let's look at one more question. The second question. The question is a 300 ohm transmission line is terminated in a load impedance of 100 plus J200 ohms. Question is, calculate the voltage reflection coefficient. Calculate the voltage reflection coefficient. Let's see that. So what is given to us? Given that ZL is equal to 100 plus J200 ohms. Also Z0 is given as 300. Yeah, but this is 300 ohms. So what are we asked to find? We are asked to find reflection coefficient, that is K or gamma. ZL minus Z0 by ZL plus Z0. चलो करते हैं 100 plus J200 minus 300 by 100 plus J200 plus 300. If you just try to solve this, what you will get? K is equal to minus 200 plus J200 by 400 plus J200. So that will give you K is equal to, if you just take 200 common, J minus 1 by, take 200 common, 2 plus J, you can cancel this. Finally, you'll get K is equal to 0.61 minus J. Right? So this is the value of K that you have got. Now let us solve one more question that is given to us. So one more question, let us try to take it. A transmission line of characteristic impedance 50 ohms is a transmission line of characteristic impedance 50 ohms is terminated by a resistor of 100 ohms. What will be the question is, what will be the Vswr in the line? Also, calculate the impedance at voltage maximum and voltage minimum. So this is the question. Now let's see, read the question once again. So a transmission line of characteristic impedance, that is Z0, 50 ohms is given, then terminated by a resistance of 100. So resistance, that is RL, or you can say ZL as 100 ohms. Now what will be the VSWR in the line? So in order to calculate VSWR, we know what is VSWR. VSWR S is equal to 1 plus mod k by 1 minus mod k. You need to know the value of k. This is ZL minus Z0 by ZL plus Z0. What is that value that you get? 100 minus 50 by 100 plus 50, that is 1 by 3. Then we need to calculate S. S is equal to 1 plus mod k by 1 minus mod k, 1 plus 1 by 3 by 1 minus 1 by 3 will give you 2. So S is equal to 2 VSWR, voltage standing wave ratio. Now there is another question given in this, that calculate impedance at voltage maximum and voltage minimum. So you need to calculate impedance, that is Z max is equal to Z0 into VSWR. What is Z0? 100, sorry, Z0 is 50, right? Look at Z0, Z0 is 50. So it is 50 into 2, that is 100 ohms. Now let's take Z minimum. Z minimum is equal to Z0 by VSWR, Z0 by 2, that is 25 ohms. Therefore, S is equal to 2. Impedance at voltage maximum is 100 ohms. Impedance at voltage minimum is 25 ohms. So this is the final answer that we got. Clear? Now let's also try to solve one more question. Let's take another question, a very good question. So a transmission line with a characteristic impedance of, let's take this question, which is, so this was the first question that we have taken, the second one and third. Now let's take fourth question. A transmission line with a characteristic impedance of 300 ohms is terminated in a purely resistive load. It is found by measurement that the minimum value of voltage upon it is 5 microvolt and the maximum value is 7.5 microvolts. Calculate the value of load resistance. So that is the question. So let's see what is given. With a transmission line with a characteristic impedance Z0, how much? 300 ohms, is terminated in purely resistive load, and it is found to it is found by measurement that the minimum value of voltage upon it is V minimum is 5 microvolt, and what is V maximum? It is 7.5 microvolt. So we are asked to find the value of load resistance or load impedance. So let's see how do we do this. We do VSWR S is equal to V max by V minimum, that is 7.5 by 5 will give you 1.5. So S value is 1.5. Now what is K is equal to? We already know that K is equal to VSWR S minus 1 by S plus 1, that is 1.5 minus 1 by 1.5 plus 1 will give you 0.33. Therefore K is equal to 0.33. Now K is also equal to, what is K is equal to? ZL minus Z naught by ZL plus Z naught. So implies, substitute the value of K, 0.33 is equal to ZL. You need to calculate Z naught 300 by ZL plus 300. So 0.33 ZL plus, upon cross multiplication, 300 is equal to ZL minus 300. Simplify this, you will get ZL is equal to 795.52 ohms. We get load value as, or you can also call it as RL is equal to, or ZL is equal to 595.52 ohms. So let's look at the question once again. So what was the question? A transmission line with a characteristic impedance was given and is terminated in a purely resistive load. It is given that it is terminated in purely resistive load, and it is found by measurement that minimum voltage of value of voltage is 5 microvolts and maximum value is 7.5 microvolts. Now we are asked to calculate the value of load resistance. So we have taken VSWR as Vmax by V minimum, that is 7.5 by 5 is given as 1.5. This is 1.5. So from that you can calculate K as 0.33. Then you can calculate ZL from this expression of K, ZL minus Z naught by ZL plus Z naught. Now let's look at one more question. The question is given something like this: a transmission line of, this is fifth question, I guess. Yeah, let's take fifth question. A transmission line of characteristic impedance 600 ohms is terminated by a reactance of J 150 ohms. Question is, find the input impedance. Find the input impedance of a section 25 centimeters long at a frequency of 300 megahertz. 300 megahertz. So the question is given that Z naught is equal to 600 ohms, that is already given, and ZL is given as J 150 ohms, and length is given as 25 centimeters or 0.25 meters, and frequency is 300 megahertz, that is 300 into 10 power 6 hertz. Now let's try to calculate first lambda. What is lambda is equal to C by F. What is C? 3 into 10 power 8. What is F? 300 into 10 power 6. That is 1 m. Now lambda is equal to that. So what is beta L? Beta is 2 pi by lambda into L. L is given as 0.25. That is 2 pi by lambda 1 into 1 by 4. So you can write it as 2 times. So pi by 2. Therefore beta L is pi by 2. We got beta L is equal to pi by 2. Therefore hence input impedance of transmission, sorry, input impedance is given by, you can write it as Zin is equal to Z naught into ZL cos beta L plus JZ naught sin beta L by Z naught cos beta L plus JZL sin beta L. So just try to substitute that. Zin is equal to Z naught into ZL cos pi by 2 plus JZ naught sin pi by 2 by Z0 cos pi by 2 plus JZL sin pi by 2. What do you get? Zn is equal to Z0 0 plus JZ0 by 0 plus JZL. So it can be written as Z0 into JZ0 by JZL. Cancel these two. So finally you'll get Zn is equal to Z0 square by ZL. What is Z0 square? 600 into 600 ZL J150. Therefore Zn is equal to minus J 2400 ohms is the required input impedance, is the required input impedance. So let's look at this question once again. A transmission line of characteristic impedance 600 ohms is terminated by a reactance of J150. So a transmission line is given first, which is having characteristic impedance of 600 ohms, and it's terminated by a reactance of J150 ohms. Now find the input impedance of the section of 25 centimeters long at a frequency of 300 megahertz. So first we need to know Z in expression. This is the Z in expression wherein you do not know the value of beta L. So we'll calculate beta L. So from beta L you need to know L lambda. So C is already 3 into 10 power 8. Frequency is given as 300 megahertz. We substitute, you'll get lambda 1. Substitute in beta L, you'll get pi by 2. Then consider the expression of input impedance. Zn is equal to Z0 into ZL cos beta L plus JZ0 sin beta L by Z0 cos beta L plus JZL sin beta L. Substitute pi by 2. You will end up with Zn is equal to Z0 square by ZL. From that, if you substitute Z0 and ZL values, you can easily get the value of Zn, that is minus J 2400 ohms. Minus J 2400 ohms. Now let us consider one more question. Let's take the sixth question. What is the sixth question? So this is calculate the reflection coefficient and VSWR. Calculate the reflection coefficient and VSWR of a 50 ohm line. 50 ohm line terminated with option A, first one, matched load. You need to calculate for this also, reflection coefficient and VSWR for short circuit. Second one, C, J50 ohms, D, minus J50 ohms loads. So these are the different loads, and for this you need to calculate what is VSWR and reflection coefficient. What is reflection coefficient? Gamma or K. K is equal to what? ZL minus Z0 by ZL plus Z0. And what is S is equal to 1 plus mod K by 1 minus mod K. So for each and every case, let's consider first what is given in this. Z0 is given already, 50 ohms of a line terminated with. Now let's consider case A, first one. Matched load. What is matched load indicates? ZL is equal to Z0. What is ZL now? 50 ohms. Since Z0 is 50 ohms. Now let's try to calculate K. 1 plus, sorry, ZL minus Z0 by ZL plus Z0. So you'll get 50 minus 50 by 50 plus 50 will be 0. When K is 0, what is S is equal to 1 plus mod K by 1 minus mod K. 1 minus 0 by 1 plus 0 by 1 minus 0. This is 1. Therefore, for match the load K is equal to 0 and S is equal to 1. Now let us consider the second case, case B. We already know Z0 is equal to 50 ohms. Now what is the case? It is short circuit. It is given as short circuit. That means ZL is equal to 0 ohms. Now in this case, what will be K value? ZL minus Z0 by ZL plus Z0. ZL is 0, minus 50 by 0 plus 50, that is 50 by 50. So K value is minus 1. So when K is minus 1, let's try to calculate what is S. S is equal to 1 plus mod K by 1 minus mod K, that is 1 plus 1 by 1 minus 1 infinity. Therefore, for a short circuit load is short circuit, that is ZL is equal to 0. What is K? K is minus 1. If you consider mod K, it is 1. And S is infinite. S is infinite. Now let us consider the third case. What is the third case? ZL is given as J50 ohms. We know Z0 of the transmission line is 50 ohms. Now what is K is equal to ZL minus Z0 by ZL plus Z0. So J50 minus 50 by J50 plus 50. That will give you, just if you just calculate that, we'll get K is equal to 1.414 at an angle 135 degrees by 1.414 at an angle 45 degrees. So K is equal to 1 at an angle 90 degrees. Similarly, if you want to calculate S, S is equal to 1 plus mod K by 1 minus mod K. So S is equal to 1 plus 1 by 1 minus 1. Again, you get infinity. So for ZL is equal to J50 ohms, K is equal to 1 at an angle 90 and S is equal to infinity. Now let us consider the fourth case, D. What is that D given? It is ZL is equal to minus J50 ohms and Z0 we already know it as 50 ohms. So what is K is equal to ZL minus Z0 by ZL plus Z0 minus J50 minus 50 by minus J50 plus 50. So K value will be 1 at an angle minus 90 degrees, and if you try to calculate S, it is 1 plus mod K by 1 minus mod K, which is again infinite. So for load ZL is equal to minus J50, S is equal to infinity, K is equal to 1 at an angle minus 90 degrees. So this is how you will solve the question. Let's see what was the question actually. So let us see that question once again. So this was the question. The question was like, calculate the reflection coefficient and VSWR of the line of a 50 ohm line terminated with, first case is matched load, second short circuit, third J50, fourth minus J50. So we take K is equal to ZL minus Z0 by ZL plus Z0 and S is equal to 1 plus mod K by 1 minus mod K, and given that Z0 is 50 ohms. So first case, if you consider the matched load case, so matched load in the sense ZL and Z0 are equal. So when you take ZL is equal to Z0, K is equal to ZL minus Z0, numerator will be 0. Similarly, S is equal to, when K is 0, K value will be 0. Therefore, S value will be 1. Now let's take the second case, which is short circuit. So ZL is equal to 0, because it is a short circuit, right? For short circuit, impedance is 0. So if you just substitute that ZL 0, you'll get -1. If you take mod of that, well, we'll get 1. So S is infinite. So for a short circuit load, ZL is 0. This is 0 actually. So this is 0 ohms, and that's why you get K is equal to -1, or mod K is equal to 1 and S is equal to infinite. Similarly, if you take the third case where ZL is load is 50 per load, J 50 ohms, and Z naught is equal to 50 ohms, K value and S values are obtained as 1 at an angle 90 and infinity. Similarly, if you take the D, that is ZL is equal to minus J50, you'll get the same. I'm sorry, K is equal to 1 at an angle minus 90 and S is equal to infinite. Now let's consider another question. So this was sixth one. So let's consider the seventh question. So the seventh question is a transmission line of 100 ohm characteristic impedance. Characteristic impedance is connected. Just give me 1 minute. Let's straight try. So a transmission line of 100 ohms characteristic impedance is connected to a load of 400 ohms. Calculate the reflection coefficient and Vswr. Now let's try to look at the solution. So this is the characteristic impedance. Z0 is equal to 100 ohms. Yeah, Z0 is equal to 100 ohms, and to the load of 400, so ZL is equal to 400 ohms. So we know K is equal to ZL minus Z0 by ZL plus Z0. So that is 400 minus 100 by 400 plus 100. So K value is 0.6. When K is 0.6, what do you get? S is equal to 1 plus mod K by 1 minus mod K. So S is equal to 1 plus 0.6 by 1 minus 0.6. So S is equal to 4. Therefore, K is equal to 0.6 and S is equal to 4 is the required answer. Right? Yeah. Now let's take up one more question. Let's say the given question is let's take up one more question with the same concept. Calculate the reflection coefficient and VSWR of a 100 ohm line terminated with an impedance of J50 ohms. So the question is given like this. So now let's say, what is that given? Z0 is given as 100 ohms, ZL with an impedance of J50 ohms. And what are we asked to find? We are asked to find what is K and what is S. So what is K is equal to ZL minus Z0 by ZL plus Z0. I'm giving this question for you. I want you guys to solve this and tell me the appropriate answer also for this. So what is that? J50 minus 100 by J50 plus 100. Just try to calculate this and let me know the answer. I've written answers for all the questions. It's your turn. So S is equal to 1 plus mod K by 1 minus mod K. Right? Now with this we have completed this part, and now let's try to solve one question on VSWR and reflection coefficient using a Smith chart. So let's take up one question. I'm just trying to take one question from this. So let's try to solve that. So I'll just note it down one question. I'll just solve it by using both. Yeah, this is the question. Now let's try to solve this question using both conventional method as well as Smith chart. Because we have seen the Smith chart, if you remember, yeah, this is what we are going to use now. Now let's start that. Now let's write the question first. A lossless transmission line with Z0 is equal to 50 ohms. This is 50 ohms. 50 ohms is 30 meters long and operates at 2 megahertz. The line is terminated with load ZL is equal to 60 plus J40 ohms. If U is equal to 0.6 C on the line, find, the questions are like this, find K, second S, third Z. So what is the question that is given for us? Just look at this question. Z0 is given as 50 ohms. ZL is given as 60 plus J40 ohms. U is given as 0.6 C. Is length 30 meters and operating frequency 2 megahertz. So except this everything is fine. So 10 power 6 hertz. Now let's try to solve this question conventionally by using the expressions. Conventional solution. So what is that? K is equal to ZL minus Z0 by ZL plus Z0. What is ZL? I'll just write it down. 60 plus J40. 60 plus J40 minus Z0 50. Minus 50 by 60 plus J40 plus 50. Simplify this, you'll get the K value as 0.3523 at an angle 56 degrees. Right? So this was the first one that was asked here. Let's just look at this. Now yes, what is yes for us? Second, yes is equal to 1 plus mod K by 1 minus mod K. 1 plus 0.3523 by 1 minus 0.3523 will give you 2.088. Therefore, S is equal to 2.088. This is the value of K and yes. Now let us see the third one that we have taken. Yeah, third one, in order to calculate third one. So what is that Zin? Zin is equal to Z0 into ZL cos beta L plus jz naught sin beta l by z naught cos beta l plus jzl sin beta l. This part is z naught. So what is Zn is equal to beta value, you need to know, right? So in order to find that beta, let's do something. Beta L is 2 pi by lambda into L. So you need to know lambda. What is lambda? C by F. What is C? 3 into 10 power 8. Frequency is given already. What is the frequency? 2 megahertz. So 2 into 10 power 6. So lambda value, you can write that 3 by 2 into 10 square. So substitute it here. So beta L is equal to 2 pi by 3 by 2 into 10 square into L value. What was the L value that is given? 30. So just try to simplify, you'll get beta L as 120 degrees. Beta L as 120 degrees. Therefore, what is Zn is equal to Z naught into, you can rather write this expression as tan, right? ZL plus JZ naught tan beta L by Z naught plus JZL tan beta L. This will be much more comfortable for us. This is for a lossless line, right? So for a lossless line, this is the equation. So that's how you'll get Zn is equal to 50 into 60 plus J40 tan 120 degrees by 50 plus J 60 minus 40 tan 120 degrees. Here you have missed 60 plus J40. Just write it down once again. So what is this? Z naught is 50. Look at that, Z naught 50. 60 plus J40. This is 60 plus J40 plus J50 tan 120 degrees by Z naught 50 plus J60 plus J40 tan 120 degrees. So if you just try to simplify this, you'll get Zn is equal to 24.01 at an angle 3.22 degrees, or Zn is equal to 23.97 plus J 1.35 ohms. So this is the value of Zn. So we have calculated K. Yes, reflection coefficient. What is this? This is reflection coefficient. What is this? Vswr, and this is Zn for a given lossless transmission line with impedance 50 ohms and 30 meters long and operates at 2 megahertz. We have calculated these things by using a conventional method. Now let's also try to do this by using a Smith chart. So let's take up the Smith chart directly. Yeah, this is the Smith chart. So first what you have to do is you just have to remember this. So let's take this in this way. Yes, so this is for us. Now let us calculate using Smith chart. Let us see how do we do this. Let's see how do we solve this by using Smith chart. The first step that you need to do is, very first step that you need to do is obtain normalized impedance. Obtain ZL, that is ZL by Z naught. What is ZL? 60 plus J40 by 50, that is 1.2 plus J 0.8. Now what is ZL? 1.2 plus J 0.8. So this is R, this is X. Look at this here. Let's say, yeah, you don't have here yeah, let us say, let us take this circle. This is 1.2. Let us say this circle, this is 1. Let us consider this as one circle, unit circle, and this as 1.2 circle, right? Next it is 0.8. So let us say this is 0.8. Now for enough. So this is where it will intersect. Now this as O, this point as O. This is the first point, right? Now second, locate ZL on Smith chart. Will already be given these values actually, but I did not take that. Just take them. Smith chart, that is R is equal to 1.2 resistance circle and X is equal to zero point 0.8 reactance circle. Find the point of intersection. Find or locate point of intersection. The way just I have done by assuming this as 0.8 and this as 1 and this is 1.2. This is how you locate it, right? Now what you have to do is then, as a third step, draw constant K circle or gamma circle you can say with OZL as radius and O as center. Now you have to do this. Consider these shapes. Yeah. So let us say with this, now let us say this is that value that we have taken. This O as the center and this as the radius. You need to draw a circle like this. Let this be the circle that I have drawn just now. Just for an assumption, just assume that this is the circle with O as the center and this point as the, this is ZL point, right? OZL as the radius, draw that point. Next, fourth step. Now this K is OP by OQ at an angle POS. Now this is, just extend this. We'll have three circles here. One is angle, reflection coefficient angle. You'll have one circle and you'll have some degrees here. This will be 50, this is 60. In between this will occur. So that will be 55 degrees. And take this P and this as Q. Measure this length and measure also this length. So this length will be 2.8 centimeters and this is 8.2 centimeters. So this will be 2.8 centimeters by 8.2 centimeters at an angle. This is PO, this line is S. Yeah. So 55 degrees, which is approximately K is equal to 0.3414 at an angle 55 degrees. The same thing that you must have obtained here, the same value, right? So we have obtained K. Now let's take fifth point. So in order to calculate, yes, for VSWR, observe the cross-sectional point of constant K circle with real axis and note the resistance at that point. So that means whenever you just draw this circle, it will intersect at this point and the resistance at this circle will give you the S value. So that is what you will get is S is equal to 2.1. So this is approximately 2 circle if you say, and this point is 2.1. So now, so this you'll get 2.1. Let's see what did we get in the previous case. It's 2.088, the same value. Now let's look at the next one. Now obtain length of line. What is the length of the line? Length is equal to 30 meters, and we know lambda is equal to u by f. What is u? 0.6 into 3 into 10 power 8 by 2 into 10 power 6. Therefore lambda is equal to 90 meters. So clearly you can see lambda by 3 is equal to 90 by 3 is equal to 30 meters, which is L. Therefore L is equal to lambda by 3. L is equal to, that means we need to travel a distance of lambda by 3 from load to generator. What is lambda? Lambda is 720 degrees. Lambda by 3 is 720 by 3 will be 240 degrees. So from this point take 240 degrees. If you just take 240 degrees, you will get a graph. I'll just take that graph. Yeah. So with this line, with respect to this line OPQ, just take 240 degrees. You will get one more line like this. This will be the line approximately, and this is this value, this angle is 240 degrees. So this will intersect, will intersect this particular value at one point. So you just need to travel in this direction from load towards the generator. So that is 240 degrees you need to travel. 240 degrees rotation in direction of generator is required to reach input. In order to calculate the input, you need that. So now we can write Zin is equal to Zin into Z0. What is this Zin? That you already got, that is 0.5 plus j 0.05 into 50. So if you observe this point here, this point will be that Zin. Now from this ZL, just rotate 240 degrees on this constant gamma circle, and at this point if you observe Zin, that is 0.5 plus j 0.05. That's what we have written. 0.5 plus into Z0 is already known. So Zin is equal to 25 plus 2.5 j, which is same as the value that we have obtained in the previous case. So this is how you will determine K, S and input impedance using Smith chart. So this is what we have seen today. So as I always tell you, we have India's #1 study channels on Unacademy, and also like this video, share this video, comment and subscribe. Use my code YSK10 on your next subscription to Unacademy. Click on this bell icon to get more notification, and click on this. Also join our Telegram and subscribe to Unacademy, the largest online e-learning platform. And thank you so much everyone for joining me today on this beautiful session on numericals on transmission lines 2.